All right, so my name's JP. Welcome to Try Swift, and thanks for all the organizers, everyone who came in from all over the world and elsewhere in Japan. It's an amazing crowd. So today I want to share a few tips from the bleeding edge of trying to build some cross-platform Swift code. I've seen quite a few people out there try to build something that's Linux specific or OS X specific with Swift Package Manager. But I think that moving forward, we'll probably want to share as much of the Swift code as possible across all the platforms where Swift is supported. So this is really just expanding beyond just embedding Swift in an Android app or writing code that just runs on a Linux server. We're really trying to have code that runs everywhere. So it can really span multiple platforms. So backing up a little bit, I work at a company called Realm. It's a mobile database that has embraced Swift from the very beginning. Actually, we ended up delaying our launch because Apple ended up announcing Swift at WWDC, and we figured that we probably wanted to support it. And not only that, but we have a number of other projects that are really tailored to the Swift programming ecosystem, projects like the Jazzy documentation generator and SwiftLint. And so we really have a vested interest in having as many of these tools, including the database itself, available on all the platforms that Swift supports. And so naturally, when Swift was open sourced, we knew this would be a huge opportunity. We've been following its progress closely since the open source announcement, and we've even had the chance to contribute a few things back to the project. But really today, our goal is to go over, if you were to write cross-platform Swift code, how would you go about doing that? And so some of the aspects that we'll take a look at are how to set up your development environment in, admittedly, a fairly opinionated way, but at least it can get you off the ground. How to use the Swift Package Manager, really just scratching the surface of what you can do to use it for cross-platform development. How to do proper testing and continuous integration as well, because we all know that we can't trust developers to test their own code, so we need machines to do it. So the first thing you have to know when you start thinking about cross-platform Swift is, well, what platforms and how many platforms are we talking about here? Well, there are exactly two platforms where Swift is supported, Darwin and 64-bit Linux. Darwin being the Apple programming environment, so OS X, iOS, watchOS, tvOS, CarOS maybe, who knows. So there are exactly these two platforms. But in reality, they're more like three platforms. Because even the Darwin platform is fragmented between the Swift binaries that Apple ships with Xcode and the open source version, the Swift snapshots. And really, it expands to a little bit more than that. So there are three-ish platforms, because a lot of great people in the community and at Apple itself are really pulling in some great contributions to get this working on Raspberry Pis, all sorts of ARM flavors for Linux, FreeBSD, even Android. A lot of good work's been done recently there. So there are all sorts of these platforms, and our goal is to really supercharge our code from just plain old Swift to something that'll run everywhere. And so my expectation going into this was like, okay, this is going to be great. I'm going to write all this code. I'm going to take all this code, all these .swift files. They're pure Swift. I'll just be able to write a bit of code, port them over, okay? Maybe a bit of work, use them in scripts. But in reality, things didn't quite work as well as I thought they would. You don't have things like Grand Central Dispatch, right? You don't even have Xcode to build for these other platforms. And so all sorts of things just don't work. Now, to be very fair, I think Apple is doing an amazing job doing all of this in the open, going extremely quickly. But it's a lot more interesting to look at the parts that still need work than it is to look at everything that's already working. So keep in mind that this is early days, and we're really bringing it upon ourselves to have all of these sharp edges if we're trying to do cross-platform Swift today with a number of pre-release versions of all of these tools. So that's fine. But ideally, if you did decide to do this, to try porting your code to make it as cross-platform friendly as possible, you'd want to be able to develop all from one machine. Right? You could set up a dedicated environment on three-ish separate machines, right, where you have Xcode and then Xcode with the tool chain, and then you have something running on Linux. But ideally, we'd be able to do all of this from the Mac. So let's take a look at what kind of setup it would take to write cross-platform code using the computer that you have on your lap right now. So those three sets of development environments that I would recommend are using Xcode for the pre-shipped and pre-built versions of Swift that Apple releases with its major tool chains, the open source tool chain in combination with Xcode so that you can continue to use all the IDE support. And then the third option would be to use a combination of Docker to run a virtualized instance of Linux on your Mac, and then to use the command line and your favorite editor to be able to edit this. So the first configuration is pretty straightforward. It's what you're used to if you've already written any sort of Swift code. And that's just plain old Xcode. Now, starting with Xcode 7.3, which is currently in beta, you can actually specify a custom version of Swift toolchain to use with your IDE, which is really nice because this means that you get all of the magic of SourceKit and you get LLDB all integrated, and that's honestly kind of nice. And so this is pretty straightforward as well. Even with Xcode 7.2, you can do xcrun, launch with toolchain, and then launch Xcode from the command line. And so this is all pretty straightforward. It can all be done via the GUI. But then the third option is a little more complex. And even then, it's just really getting started that's a little more complicated. And so here's how I would recommend that on the Mac, you have this integrated environment where you can develop for all of these three platforms. I'd really recommend that you use a tool called Docker, which is a virtualization environment that usually uses any sort of virtual machine provider, in this case, most likely VirtualBox. And all you really need to do this is homebrew. And then if you follow these 4 or 5 commands, then you have a Linux environment running on your Mac that's completely isolated from the rest of the system. And then the important part here is that you mount whatever local directory that you're working in. So say that you're working on your new hot module framework that you want to share across platforms. If you're in that directory, running that last command, that docker run, allows you to mount that directory into the Docker environment, which then allows you to continue using the shell that you're familiar with in terminal. It allows you to continue using your favorite editor, something like Sublime Text or Atom or TextMate or even Xcode, while you're making changes to the Swift code base. And so it's really convenient. And the alternative is if you don't want to do this, you can just create a new directory in your container and use something like Vim or Emacs or whatever the terminal editor of choice is these days. So by doing this, the only thing that you're ever doing, that you're ever forced to do on the command line is Swift build and Swift test and commands like that. And so you can continue to use the same environment that you're familiar with and that you know and love to hate. So the next thing I want to share is the Swift Package Manager, which Ikeda shared a little bit about earlier. It's a great tool for building and pulling in Swift dependencies. And of course, it has to coexist with CocoaPods and Carthage, but in the case of cross-platform Swift, it's really the only way to build it. Mostly because both Carthage and CocoaPods rely on Xcode doing the actual building, which is not cross-platform, as we all know. And so I'd really encourage you to use SPM, even if you're just building a single executable. Most of the time, if you manage to architect your code in a way that you can use frameworks and modules and unit tests, you'll end up thanking yourself later. And there's really just a very small upfront cost in kind of understanding these set of tools, but once you know them, it then becomes second nature to create a little framework for some set of core functionality. And I think Ayaka later in the conference will share working with boundaries and how you can help really isolate parts of your code from another. And so this really helps by doing that, by having the Swift package manager build explicit modules for containing functionality or anything else that you want to do. So I'd really encourage you to use the Swift package manager if you're doing some cross-platform Swift. Now, the next thing that you'll probably bump into if you're doing some cross-platform Swift is that there are a few things that you just expect to work out of the box. And unfortunately, these things may seem simple, but they have some hidden dependencies, such as dependencies on the Objective-C runtime for things like the dynamic keyword, which is a keyword used, it's a language feature that's used for dynamic method dispatch. And you can use this for properties, say. But ultimately, even though it's a Swift feature, it depends on the Objective-C runtime. And this is something that the Swift team has explicitly said that they want to help remove this dependency on the Objective-C runtime, because one of their goals for Swift 3 is portability. And so the Objective-C runtime is only available on Darwin platforms, which is a major problem when it comes to this portability. But it means that if your Swift code, even if it's pure Swift, and it's using the dynamic keyword, well, good luck. You're going to have to port that and find some other mechanism in order to use it in cross-platform Swift. Other things that you'd expect to work are casting. Castings when you convert one type to another type. Well, a lot of that also depends on the Objective-C runtime. It's kind of hidden by the language, and it takes you by surprise. And of course, some major and very important frameworks that Apple provides are Darwin only. Foundation, Grand Central Dispatch. Now, thankfully, Apple has really made the amazing decision of porting these frameworks to Linux and to the other Swift-supported platforms. So this is going to be great, and really the lack of this functionality from these modules should hopefully just be temporary. And then there are other few things like the automatic import of frameworks, which Xcode tends to do for you, and you kind of have to remember if you're using Swift build. So as an example of this, one of the simplest, I shouldn't say simplest, but something that I expected to be straightforward to port to Linux was the result library from Antitypical. And so the result library is kind of an alternative to the Swift 2's error handling, or another way to look at it is a type alias to the either type, right, where you have a success case and a failure case. So as far as libraries go, this would probably be called a micro library or a micro framework. So it's fairly self-contained in its function and doesn't really tend to use a lot of esoteric Apple frameworks and things like that. And so to port it over to Linux, you would think that it would just mostly work. And you would actually be right, except for a few little niggling things like this casting error, which is actually trying to cast an error, which is not working. Now, this relies on the Objective-C runtime, and so even though it just looks like pure Swift language features here, the top version of the diff is what it was before, and that type of casting just doesn't work on Linux. And so you kind of have to shift some things around, do the casting elsewhere, do different types of casting that result to different behaviors under the hood in order for all this to compile on as many platforms as possible. So that's just a bit of a gotcha. Another thing that you'll find yourself doing a lot to work around some of the fragmentation that we're already seeing in the Swift ecosystem is use these compiler-defined ifs everywhere, where you're checking for either the usage of the Swift package manager, where you don't have access to all the system libraries and frameworks. So this is an example of the 3-ish platform where you're still building for Darwin, but you sometimes need to perform different actions depending on if you're using Swift package manager or Xcode. And then something that you'll see a lot is these checks for the architecture. So for example, checking to see if the operating system is Linux and then not using GCD for something, or not using some other available Apple framework, or not using the Objective-C runtime, even in some hidden ways. And so this is something that you just have to get used to, and really over time, we'll see these limitations reduced as the Swift team and outside contributors really try to converge and help with Swift 3 portability. Now let's talk about testing. Testing, very important. I actually wrote this talk before the latest Swift snapshot. So let's take a look at what testing via the Swift package manager looked like up until a few weeks ago. If you wanted to use XCTest, you essentially needed to clone the Apple-provided library because it didn't have any of the Swift package manager required tags that you need to actually expose it as an external dependency. And so you needed to fork it and then build it as a dependency, not as a test dependency, but as an actual dependency of your module. And then have another package. See this target my package tests? This isn't built as part of the test. This is actually built as part of your actual package. So this test bundle needed to depend on the thing that you were actually testing. And so it was all sorts of hackery. Now, thankfully, there was a fairly major rewrite recently, and this is available in the latest Swift Package Manager snapshot, where the Swift Package Manager will just look at the source layout of your project on disk in the file system and automatically create test targets for this. And it'll use Darwin's XCTest framework if it's available. Otherwise, it'll use the snapshot provided XCTest version, the one that's built with Swift. And so by doing this, you have access to @testable. You can actually only build your packages when you're distributing them rather than also building your tests along with them and all of XCTest to go with it. And there's a few things that you do need to do differently on Linux. Because the Swift XCTest version, as opposed to the Darwin XCTest version, doesn't have the runtime reflection capabilities that the Darwin version has, you have to explicitly say what all of your test functions are. And so that's where you'll see something like xct main for this Linux main file. It's telling XCTest explicitly what all the function pointers for all the test functions are, rather than the Darwin version, which just automatically figures all that out. But nonetheless, this is a major simplification. So really pretty happy with this. So this is going in the right direction. Now, odds are that you'll want to set up CI, continuous integration, for your cross-platform Swift code. And really the one piece of advice that I'd have for you is test all of it and embrace the build matrix. So let's take a look at what it would take to set up integration tests or continuous integration tests with all of our 3 platforms using something like Travis CI. But of course, you could do this using Jenkins. You could do this using probably some level of Xcode bot or Circle CI. But the Travis configuration is fairly simple, so it's easy for me to present up here. So in this case, you'd have, this is kind of a simplification of the Travis file. But ultimately, all of the code for it we're going to see in just a second. So you want to run these 3 platforms. So OS X with Xcode, OS X with Swift Package Manager, and Linux. So the Xcode version is what you're already doing. If you've already set up continuous integration tests with your framework or with your app, just keep on doing what you're doing, right? And so use whatever external dependency manager you're using, CocoaPods, Carthage, submodules, whatever you like. And then for OS X with Swift Package Manager, it gets a little hairier because then you actually need to download the Swift snapshot and tell your path to actually start using that version of Swift rather than the version of Swift that comes with Xcode. But still fairly straightforward. You can run Swift build and then run the test afterwards. And on Linux, it's not that more complex either. You essentially do the same thing. You download the Swift snapshot. You set it up in your path. And from there, you can build your Swift code and run the test for it. So, if you want to take a look at this configuration, there's a number of examples that I will link to in these slides. They'll be made available. So once you've done that, you're probably feeling pretty good with yourself, because at this point, you're confident that your Swift code runs, is tested on all these platforms. So keep in mind that all this is kind of early days. If you're watching this video, it's probably already out of date. But one of the reasons I still wanted to share this is at least in a way to document how it is today, and probably the great leaps and bounds that the Swift projects will take in the coming months. But also, if you do want to get an early start, hopefully these tips will help you out. So in the meantime, I really encourage you to contribute back to the Swift open source projects, whether that's the standard library, the foundation spinoff, the Swift XC test, or the compiler, or anything at all to help minimize these kind of rough edges when it comes to portability. I'm sure Apple would love to merge some of those pull requests, since one of their goals is portability. So thank you very much for your time, and enjoy the rest of your conference.
Hi, JP. It's Veronica. I have a question about whether you see Xcode being able to be run on non-Darwin OSs in the future, and how that would improve the ease of cross-platform development if that happened.
Thanks for the question. Thanks, Veronica. The question was, would we foresee a version of Xcode that runs on non-Darwin systems? And my answer there would be probably not. If that were to happen, that would happen inside Apple itself. Xcode is not open source, although the Swift team has really done a phenomenal job trying to extract out sets of functionality. So the compiler process used to live as part of the Xcode process itself when it came to Objective-C and Clang. Now, with Swift, as you've probably noticed, SourceKit is a thing that likes to crash, or at least in the past liked to crash a lot. And thankfully, that was early days, and it's been a lot more stable recently. But the reason why you had that heads-up display saying that SourceKit service crashed was that it lives outside the process. And so most of the IDE support actually lives outside of Xcode when it comes to Swift. So that's where when you hear frameworks and names like SourceKit or libIDE or libparse or SourceKit inproc, those are all sets of tools that are actually open source as part of the Swift project, that some of which are portable across platforms. Others, like SourceKit, is Darwin only. But essentially, you could port SourceKit to Linux and then have all of that IDE support, like code completion and syntax highlighting and things like that, and symbol resolution. So you could do something like a command click to symbol without ever needing to open source or port Xcode itself. And so there are people working on that porting effort right now, and I'm sure it'll happen in due time. So you're not going to see Xcode cross-platform anytime soon, I think, because Apple's made it clear that they want to share other parts of the tool chain across platforms. Okay, one last question. Daniel?
Thank you very much for the talk. It's a bit of a throwaway question, but I was just really curious as to what part of the cost you mentioned in the result library depended on the Objective-C runtime.
That's a great question. What part of the casting as part of the result library depended on the Objective-C runtime? I don't know. One of the conceits that I'll make right now is that I'm having a really hard time debugging the compiler parts, and not only the compiler parts, but also essentially everything that lives in the Swift project distribution. And so I know it's certainly possible to use LLDB with the compiler, but ultimately it's not something that I've been able to do. So you'd essentially have to be a better debugger than I am to try to figure that out, which isn't asking for much. I'm sure you could figure it out.
So I mean, it's probably easier to say than if it doesn't work, then it depends on the Objective-C runtime.
Yeah, it is a bit of a wild guess the fact that it depends on the runtime, but I know that some other parts of the casting story do depend on the runtime, so it's a bit of a stab in the dark. And one of the reasons why I think it depends on the Objective-C runtime is that that's the mechanism that's used for runtime type resolution. And so for a dynamic cast that is done at runtime, I would expect that that is somehow linked, but it's quite possible that it's due to something else.
Thank you very much.
Thank you. Thank you.
Thank you, JP.